So what I'm trying to show here is how this spatial modeling framework can be used to evaluate map products. This is Cloquet Forestry Center, which is in northern Minnesota. We can zoom out here and kind of see where it is, but it's a research forest for University of Minnesota. So we got lots of really nice field data here, and then we also have the Minnesota statewide LiDAR, and I clipped out 95th percentile height over Cloquet Forestry Center, and then just built the spatial model and predicted biomass for these areas, and this is what that map looks like. And over here, I ran the exact same model, except I held out the LiDAR variable P95. So now there's just an intercept in the model. So basically what it does is it turns into an interpolator. You can think of these as like kriging interpolations, but it's still within that hierarchical spatial model framework, so we can get at the uncertainties in this map in the same way that we can here. So by having these two maps, we can actually compare what our mean predictions are and our uncertainties for this one to this one. And if the one with the LiDAR data is better than the one without LiDAR data, we could argue that the LiDAR data is improving our predictions in that area. So this is a sort of small area estimation tool, but I can show you how this thing works out here. So this little box allows me to draw a box around it. So at first I'm just going to draw a box around the entire forest and then calculate, and then that will calculate my biomass mean with a 95% credible interval, and then it also gives me total biomass, and then this forest area is just the number of pixels times the area of that pixel. So that's how large Cloquet Forestry Center is. So we see here that we estimated 21.48, which is this red line on this posterior distribution here. And then these dashed lines represent that 95% credible bound. So we're 95% sure, based on this map, that mean biomass is somewhere between 21.3 and 21.7 megagrams per hectare. Now on this map, if we do the exact same thing, we pull up the posterior distribution for this, and we can see that its estimate's a little bit different. It's a little bit higher, so 23.67, and then our credible interval here. Notice that our credible interval here is a little bit more than 1 megagram per hectare, and over here it's about half a megagram per hectare for density. And you can see that corresponds in the totals too. So given this, we can say that that LiDAR data, that LiDAR map, is actually improving our ability to estimate biomass for Cloquet Forestry Center compared to just using the field data in this place alone. But what's fun here is we can actually, so this tool allows me to draw arbitrary shapes. So we can go in and just kind of, here I'll try to do something we might be able to mimic in the other one, but I don't think we're going to be able to. So this just tells me mean biomass inside this triangle, and then tells me the size of the triangle and all that fun stuff. So we can see as we go to smaller areas, our credible interval gets wider, so which is actually a nice feature. It's pretty easy to, it's much easier to get the average for the entire forest than get an average for a really small area. We can actually go even smaller. Let's just grab just a few pixels, and then we can see that my range is actually quite large now. So we're not so certain exactly how much biomass is in this triangle, but as we kind of get larger and larger, we can become more and more confident about how much is in there. So we can see that that is quite a bit narrower. So we can use this type of approach to compare different maps. So maybe instead of bringing in that LiDAR data directly, we bring in Sylvia Terra's biomass map for this particular area. We can go in and we can calibrate that map to the field data in the area, and then make a map based off, make our small area estimation product based off of their map instead of the LiDAR data here, and then we can compare it with a null model, or we could compare it against one that's just using LiDAR data, and then we could actually see, if the Sylvia Terra map is improving our ability to estimate biomass over and above using the LiDAR data alone or the field data alone.